All right, so I'm gonna draw the counterbalance valve. With a check valve. Okay. Okay. So this one here is a pilot. Depend on how much ratio. This one here is like a relief. Okay. Spring. Adjustable. Okay, sometimes it's vented, so this time we just put it like that. So the way it works is normally in this system there's two counterbalance valve in one cylinder, because this counterbalance valve is like a brake valve to prevent the cylinder overrun, especially there's a load. So we just put a cylinder here. Okay, then let's put a load here. Okay, kilogram. All right, so this one we put this on the, so let's put a red stuff. So this one, let's say on the retract. Okay, all right. Now we're gonna draw the extend. So this is interesting, Noah. Okay, all right, so here just put like that, and then pilot. Okay, and then check. Okay, spring, make sure we're not missing. And then all right, so this is number 1, number 2. Normally on the Sun hydraulics they put numbers on ports. This is 3, so this one here will go like that. It's a brake valve. Okay, all right. Okay, so meaning what happened, we put the red stuff here, red line. Okay, all right. So when you extend the cylinder, so this one, let's put this one CB and then CR. We use the portings on the drill because this is on the drill. So what happened is when you extend the cylinder, so the flow go here, so won't go there, so we'll check valve, through check valve, and then act on the piston side. Now the cylinder will not move unless this rod, the oil on the rod side will drain. So what happened, the oil on the rod side is won't go there because there's a check valve, and here it create pressure here. So this will be the CR and CB. Okay, now if this is act as a to prevent the overrun. So if you don't have that, the cylinder will, especially if you use that cylinder as a jack, so it will overrun, then it will create cavitation, then the system fail. Okay, so they have that to counterbalance, that's why, or or brake valve. Okay, now this pressure here will create due to the force that acting the piston, and then it will create a pressure intensifier. So this pressure here will increase. And then of course you have your supply CB, because that's the flow coming from. At the same time, this pilot here act on this piston. Let's say this one is 4.5. Ratio is to 1. The way it's set, this spring, let's say this spring is so here, this is help. Okay, so the pressure to overcome, the force to overcome the spring is the pressure from your CR and the pressure from your CB, but that's depend on the ratio here. All right, let's see. So this one, if we set this spring setting is 3,900 psi. All right, psi. Okay, now we're gonna set this pressure here because it says 4.5 ratio. But yep, so you understand how it works now. Without the counterbalance, if you have a supply on your piston side, if there's a load, the jack, if you use this as a jack, the jack is uncontrollable. Yeah. Let's say if you're commanding only a low speed, you can't attain that because of the load. It will drop. So you have that counterbalance. Now this time here, to set the counterbalance valve, the graph should be like this. This is CB, pressure, and then this is CR, force. Okay, the way it's set, if it's a counterbalance, there is a zoning. So this zone here, it's kind of like that. So that one there, this zone, this is the cylinder no moving zone. So see that pressure, this is pressure here, PSI. All right, so to set that, it should be like this. Okay, there is too many methods to test this counterbalance valve, but the graph should be the same like that. In this zone, the cylinder is not moving until it reaches this pressure here. Okay, now we have a 3,900 psi, and then we have a ratio of 4.5:1. Okay, the way it's set is CB. So CB is equal to spring force or spring setting, SS, minus the CR over the ratio. Okay, now what is our spring setting? 3,900 psi. All right, that's good. So 3,900 psi minus, so this CR here, which is this one here. So you can assume, you can put 1,000. Okay, let's say 1,000 psi over, what is your ratio? 4.5. CB now is, if you calculate that, so you minus first, that is 29, divide 4.5. Now 3,900 less 1,000 equals, you don't continue, less 1,000 equal, divide 4.5, 644. So this one here will 645 psi. All right, so the way we set now is we put 1,000 here, constant, and then here we varied 645. So we slowly increase the pressure here until 645, and then we should be able to read the flow. So if we put this on the test bench, we put a flow meter here, a flow meter. So the flow will read until we reach the 645. So if less than 645 and then you have a flow, then we have to adjust the spring. So that's how. So no movement. So we here at 645 psi, that's the time the cylinder move. Okay, that's the ratio at 1000 psi on your CR. So that is your force, 1000. Okay, all right, let's do that one. So this is the counterbalance valve, the way we set it up. So this one is the port 3, which is the pilot. This one here is the port 1, all right, which is the CR. This one is the CB. This is from the piston side of the cylinder. So at the moment we set this because the ratio is 4:5, 4.5:1. So meaning if we put 70 bar on port 1, we need at least 45 bar on pilot port 3. So now we use this hydro technique, and we can see the graph here. All right, let's turn on that other leak. Okay, switch that on. So the P2 is okay, let's go on, let's reset. Alright, now the P2 now is 70, so wind in the P3. Should be able to get 45 plus and minus up. So now, alright, so you need to wind slowly. Wind back out. Wind out all the way. So we wait for 70 and then wind in slowly. That's 20. Slowly, and then I'm gonna reduce the P2 because it's 70 here. Hang on, wait for a minute there. Stop a little bit. We're gonna maintain that 70 bar. Alright, wind in. Wind in. Keep going. Going. Keep going. More. Going a little bit faster. Keep going. little bit faster. Alright, so that stop there. So that one there, 30. And so go down. Okay, more. 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 Keep going. 40, slowly up. 40, hold there, hold. Around 44, yeah, that's good. So go back, out. Alright, see, and then wind in, keep going. Up. So around there, between 44, the valve is open. So that's good now. Alright, that's good. So to increase the pressure, you need to wind this out. So this is opposite. If it is counterbalance valve, if you want to increase, you turn this wind out. So if you decrease the pressure, you wind in. So decrease clockwise, counterclockwise, increase. So that's good. So guys, so I will show you the graph and then I will explain how the counterbalance responds in relation to the pressure. Okay, so this is the graph here. So this red one here, which is the P2, that is your acting on the port number 1 of the counterbalance valve, which is in our circuit before. This is CR, okay, on the rod side. So the rod side will not open until the pilot pressure, which is the 4.5 ratio, which is on the piston side of the cylinder, will reach in a certain pressure. So the setting is so this is bar. The setting is, if the spring setting is 3,900, so let's divide it to 14.5. That is 270 bar. 270 bar minus, so it's go 1,000 psi, divide 14.5, 69, so less 270, that is 210 divide 4.5, which is 45 bar. So here 45 bar because it's a 4.5 ratio. So if you reach the 45 bar, that rod side pressure will start moving. So the cylinder now will start moving at 45 bar on your pilot port, which is the port 3. Okay, so here there's no movement. So the cylinder is not moving until it reached that 45 bar here. So once that reach, see that it dropped, so meaning the valve is open, so the cylinder start moving. So in here, in this graph here, we can tell that the force is, on the graph before that I show you on the whiteboard, you know, that spring force or the rod side force in relation to the pressure, the zone on that cylinder no movement we attain. Okay, so let's say this one drop at 35 bar, let's say. So you have to increase the spring on the counterbalance valve. Now to increase the spring is opposite, which is counterclockwise, increasing the pressure, increasing the force of the spring. Clockwise means decreasing. So that's how you set the counterbalance, is opposite. So yep, so we're happy with this test result, and then we can proceed to we can test the other remaining counterbalance valve. So hope you understand the counterbalance valve, how it works.